So this was question 5 and this will be question 6. Yeah. So question 6, it is asking for what is the span of a matrix. So the span for the span for the span so I'll just first go with the definition given here. So a set of vectors spans a space if every other vector in the space can be written as a linear combination of the spanning set. But to get to the meaning of this, we need to look at the matrix as made of column vectors. So here's an example. Okay, so they have given a matrix M that is 1, 2, 3, and 5. And so basically for span, what they have done, they have divided this matrix into column vectors. So basically, if you're not familiar with vectors in like engineering or especially in case of MATLABs and computer programmings, we encounter with these terms like column vector, row vector. So um, in this case, um, we'll just divide this matrix in two column vectors. So basically, what is a vector? A vector is a matrix of single column or single row. So it can have like n rows but one column, that will be column vector, or one row and n columns, that will be a row vector. So I can divide this matrix. So M was a matrix, then into two column vectors. So let's say first vector is, let's say M1, that will be 1, 3. So again you can see that we have only one column but two rows. And then we have M2, that is 2 and 5. Um, so this has column vectors 1, 3 and 2, 5, which are linearly independent. So the matrix is non-singular, that is invertible, and etc. Now let's see what they are doing. So let's say that we want to show that the generalized point x comma y is the span of these two vectors, that is, so the matrix spans all of R square. Then there are scalars a and b such that, so there is going to be a condition, that is, and this will be b times 2 5 equal to x y, and we can just multiply these scalar terms. So this will become a 3a, and this will become, b, we have to multiply b, so this will become 2b 5b, this will be xy, and this is a set of linear equations, so we can just separate them. So this will become a plus 2b equal to x, and this is 3a plus 5b equal to y. Now let's see what they are doing here. So they are solving this equation. Okay. Mhm. So let's say they are solving this equation for A and B. So A will be okay. So they have okay. So they have solved this simultaneous equation, and what they have done here, if I multiply 3, this will become 6. Let me just do this. This will be 3a plus 6b equal to 3x, 3a plus 5b equal to y, minus minus minus. So this will become 6b equal to 1b, or b, just b, is 3x minus y, and then we'll put the value of b here. So this will become a equal to x minus 2 6x minus 2y. This will be plus, and this will become minus 5x plus 2y. So it will become minus 5x plus 2y. Let me just cross check. Yeah, so we'll just solve these two equations to get for a and b. And now what we'll do, let's say a is -4. So basically, to check the span for this matrix at 2 comma 3, so a is -4 and b is b is 3. We just go for that simple case. So this will be 1 3 plus 3 times 2 5, and I'll just calculate this. So this will become -4 and 3, and this will become okay, for 2 and 3. Okay, so basically we'll be keeping this 2 and 3 in these equations, this one and this one, and we'll just check this, that whether in the LHS we are getting 2 and 3 or not. So this will be 4, 3 2s are 6, so -4 6. This will be 3, this will be -12, and this will be 15. So 15 minus 12 will be 3. Yeah. And okay, so in the next step they have done the same thing only. So I guess that is all for this question also. I'll just write that the solution given here was correct. Like the span of the matrix, we generally don't do such kind of problems. We just do it directly. So correct solution. Good work. That